All right, let's take our discussion and understanding of p-value and see what that does for us in terms of making a decision about the claimed null hypothesis. Okay, so that's our goal, is to now make a decision about the claim of a null hypothesis. Are we going to reject it? Do we have evidence to reject it, or do we not have evidence to reject it? Okay, so let's remember that we've got that p-value definition. P-value was the probability of getting these sample results or something more extreme if the null is true. Okay, so if the null is true, then that's the probability of me getting those results. And then we discussed this very briefly at the beginning of our p-value lesson, but I didn't bring it up very much more. But now it plays a very important role. So alpha, which is this Greek letter alpha here, lowercase alpha, it represents the size of the rejection region. That is this size and the location and the proportion of samples that would lead me to say, hey, this this sample is really far away. I am going to reject the null hypothesis. Okay, so I have two situations here. Let's go ahead and take a look at this first one. I think I'm going to kind of hide some of this as we go along. Okay. All right, so here we have a picture. And you have this same picture drawn, but I added in this little red shaded area, which is alpha, the size of the rejection region. Now, here is the sample that we got, the p-hat. So, as we have been doing, here's the p-value, this area to the left. So see all of this section here that is blue is the p-value, the probability of getting that sample or something more extreme. Okay, so notice where this sample is located. Is this sample in the rejection region or not? And so then, of course, I've pointed to it. It says the sample results are not in the rejection region. So let's compare the size of the blue area to the size of the red area. Which one is bigger? The p-value is greater than our alpha because you can see there's more blue than the red. And for those of you who have trouble with the little inequality signs, man, I'm sorry, but you're going to have to get this figured out, okay? You got to have to figure out how to do a greater than sign. This is the first part of this symbol is big, so that it's a greater than. So our p-value is greater than alpha. The alpha is the little part, and the p-value is the bigger part. So the p-value is greater than alpha. Okay, you're seniors in high school. We need to graduate from Aledo High School knowing how to do an inequality sign. Okay? All right. So our p-value is greater than alpha. So now, then let's talk about a decision. Do we have the sample in the rejection region or not? So the sample is not in the rejection region, so we fail to reject that null hypothesis. So we do not have enough evidence to reject HO. Now, I'm going to take a moment because I struggled with this statement when I first learned statistics. I was like, why do we have to say this double negative? Why can we not just say, oh, HO is true? I accept HO. Okay, there's a reason that we are not allowed to say that. And I'm actually going to jump over here real quick because since this is brought up, I think it's applicable to come on over here and take a look at that. So let's take a look at the bottom of your second page, because it is never okay to say that you accept the null hypothesis. And so let's think about this situation of somebody being accused of a crime. In this case, I think pop culture reference, we're familiar with O.J. Simpson situation. And so the null hypothesis, of course, you're innocent until we have enough evidence to say you are guilty. Okay? So let's think about this. If we do not have enough evidence, if we don't have enough evidence to say he is guilty, does that mean that he is innocent? Well, I don't know if you know the story, but from what I know, I highly doubt it. I highly doubt that he is innocent, okay? We just did not have enough evidence to say that he is guilty. So we didn't have enough evidence to reject the null hypothesis. So it stays, it holds, but I'm not saying it's true. I'm just saying I didn't have enough evidence to reject it. Okay? Very important distinction there. All right, let's go on back to this page. And we'll take a look at the other situation that can happen. Here we have this where we have a look at the red area, which is alpha, the size of the rejection region. And look, that p hat is down in that rejection region. And so the p-value is this small little blue area. So the p-value, so which one is bigger? Or tell me p-value's relationship to alpha. P-value is less than alpha. So since that p-value is less than alpha, you write this symbol here. P-value is less than alpha. See, the p-value's got the small part of the inequality to it. So guess what? If that p-value is small, that is happening because the sample is in the rejection region. So if the sample proportion is in the rejection region, then what decision should I do about the null hypothesis? Do you think, if this one is far enough out there, do you think the data is really centered around this null hypothesis? And that answer is no. We reject the null hypothesis. We have enough evidence to get rid of HO. We get rid of HO and we say, hey, I think the data is centered in this case somewhere lower. All right. So we have this little song here, of course, a little song, to help you remember these. It's important conceptually that you understand what's going on, and so I've showed that to you, but we have a little thing to help also. So if this p-value is low, meaning lower than alpha, then we're going to reject the null hypothesis, reject HO. So if the p-value is low, reject HO. Now, some people like to say, reject that ho. And, we do not say ho and ha. We say HO for the null hypothesis or HA for the alternative. But I realize that to some of you, it might be fun to belt out, reject that ho. So if you learn nothing else in statistics this year, hopefully you'll learn how to reject that ho. All right, so if the p-value is low, we're going to reject HO, and that null hypothesis has to go. All right, we have a song on that, so let's get to it and let's play that song. Here we go. It goes to You Ain't Nothing But a Hound Dog. Here we go.
If the p-value is low, if the p-value is low, the null hypothesis has to go. the p-value is low, if the p-value is low, the null hypothesis has to go.
All right. If that p-value, and there's our definition of the p-value song. Let's see if I can stop that. Okay, there we go. Remember the p-value song? If you remember then, we used to sing. Okay, so let's now put this into action. Okay, I want to give you a moment on the next page to, to think about this. Okay, so if we reject the null hypothesis, then our decision, so if we reject HO, then what we say next is if you have evidence or you do not have evidence of HA. Okay, so let's think about that. So let's think HO and HA. If you reject HO, then you have evidence of HA. That's important. Okay, but let's look at this other situation. HO and HA, let's discuss. Now, I'm not going to circle HO. I'm going to put a dotted line around HO because not saying it's true. I'm just saying I don't have enough evidence to reject it. Okay, so dotted line because I cannot say HO is true. I just did not have enough evidence to reject it. So then we do not have evidence of HA. We do not have evidence of HA. So that's how I want you to think about these next little these next little pieces. I want you to stop the video and take a moment to look at these values. And what you're going to do with these values is you're going to just compare your p-value to alpha. Okay. And after you compare your p-value to alpha, then you're going to make a decision about what you're going to do with that. Okay, so let's also see if you can get the correct inequality statement. Okay, I kind of gave you that first one there. All right, so pause the video and then we'll get back with you and look at the answers. All right, so let's take a look here. So hopefully you know your decimals and that you know that this 0.067 is greater than 0.05. So that's the alpha. So since it is greater, it is not low. So since the p-value is not low, I do not reject HO. So I fail to reject HO. And if it might help you. So here's HO. Oh, I need to, if here's my HO and here's my HA. If this holds, then I do not have evidence of HA. So that's what my result is then here. I do not have evidence. Okay, next one, the p-value is low. So if the p-value is low, reject HO. The null hypothesis has to go. So I do have evidence for HA. All right, number 3, it is greater than, no, it's, wait, what? Okay, I have this wrong here. So let's fix it. 0.1, I guess I was thinking that was 0.01 when I did that because 0.08 is definitely not greater. Okay, so let's fix it. So this is a less than. So this is a less than. All right, so my things are going to be wrong. P-value is lower than alpha. So if it's low, then the null has to go. So I am going to reject HO. And if I reject HO, then I do have evidence of HA. I'm rejecting HO and concluding HA. All right. So next, Now this p-value is definitely greater. 0.125 is definitely greater than the alpha of 0.03. So my decision is going, so greater than, not low. So I'm going to fail to reject HO, which means I do not have evidence of HA. All right, this one is low. P-value is low. The p-value is low, so I'm going to reject HO, so I have evidence of HA. All right, and the rest of this is that discussion about how you cannot say except the null or that HO is true. And we will always be making our conclusions in context of the problem. Context, context, context. We're done with just regular old mathy stuff. We're putting the math to real life. So if everything's always in context. Okay, so let's take a look at these problems. So when you turn the page, you'll notice that I actually gave you the first few parts. Okay, I gave you the parameter, the hypothesis statements, and the p-value. And that's because we had done those previously in another section. So I wasn't going to have you redo them. So I want us to focus on the part of this problem that is how to, let's see here. I want you to focus on getting the p-value and comparing it to alpha, okay? And then making a decision and so on and so forth. All right, so here we go. So this is the problem about the jury selection system and seeing if the proportion of the jury selected that are Hispanic, P equals the proportion of the people selected for jury duty who are Hispanic, seeing if it's actually the same, consistent with the county Hispanic rate. Null hypothesis, it's 0.19. Alternatively, we thought we might have too few, so we say it's less than. Okay, so in our previous, or when we do the p-value, we got 0.079. So next section says to compare a p-value to alpha. So alpha is called the significance level because if our sample is in the rejection region, it's considered significant. And I go up here and I see they did not tell me a significance level. So you need to know that if the significance level or the alpha has not been told to you, then there is a default alpha, and that is 0.05. So if we are ever not told alpha, then we can claim it to be 0.05. So here is how that looks down here when we compare our p-value to alpha. So, and this, I want this exactly like this. No difference. Do not just put the numbers. You are defining what these numbers represent and comparing them in one line. Must be exactly like this. Also, don't you dare put P equals 0.079. Because if you put P equals 0.079, excuse me, up here you told me P equaled 0.19. Okay, no. P value is different from P hat, which is different from this P in the null hypothesis. Okay, so that's why you have to write the words P value. All right, so it equals 0.079, which is greater than alpha of 0.05, greater than alpha. So what will our decision be? It says make a decision. What will our decision be if that p-value is not low? Then we fail to reject HO, and we do not have evidence of HA. So here's so then this statement here will say, there is not evidence to conclude that, okay? And so then we just state HA in context. So look, I drew a little arrow up to here. So we do not have evidence of this. So technically what's happening is this is going to hold, and we do not have evidence of this. So some students find it helpful to do that. Again, not saying HO is true. So our evidence or not evidence is always a statement about HA, never about HO. Our evidence or no evidence is always about HA. So I say, I do not have evidence that proportion of people selected for jury duty who are Hispanic is less than 0.19. So I'm just basically writing this out in context. So I failed to reject HO. So I do not have evidence that the proportion of people selected for jury duty who are Hispanic is less than his 19%. I do not have evidence that. Okay, and so that's what that shows there. Now, I always like to stop and think and double check. I, at this point, go double check and see if there was another question I needed to answer. So I go up and I reread, and it says, do these sample results, right here, do these sample results call into question the fairness of the jury selection system? Well, what do you think? Did we have evidence of it being a lower rate? No, we did not have evidence of it being at a lower rate. So, do you think this is calling into question the fairness? And so I say these sample results do not call into question the fairness of the jury selection system. Okay, and so I drew that blue arrow up there to the additional question that was asked. All right, that's how we do it. So let's try one more and see if you can kind of guide yourself through this one on your little more on your own. So this is the problem about the home field advantage. We want to know, is there strong evidence of this legend of a home field advantage? So I gave to you this information. P equals the proportion of regular season games won by the home team. If there is no home field advantage, nothing special going on, it's 50%. If there is something special going on, then it's greater than 0.5. Okay. So here's our p-value. Woo, 0.0062. That is low. How low can you go? And I got mad at you guys for not doing the right inequalities, and then now here is two of them that I did not do correctly. What is wrong with me? I do not know. So that p-value is less than alpha of 0.05. That p-value is low. So if that p-value is low, reject HO is your decision. All right, so then if we reject the null, so we are rejecting the null hypothesis, so we do have evidence that, and then you say this in context, the proportion of regular season games won by the home team is greater than 0.5. So there is evidence to conclude that the proportion of regular season games won by the home team is greater than 0.5. And the question, remember, always look to see if there's an additional question. Is this strong evidence of the legend of home field advantage? I think so. This supports the legend of home field advantage. Okay, and you know what else I just noticed? Look here. This is a 1% level of significance. What's that? Oh, well, guess what? That means that I wrote this wrong. This alpha shouldn't be 0.05. This alpha should be 0.01 because it said a 1% level of significance. So I'm glad to go through this video so I can kind of go back and check, fix the answer key. All right. So there you go. This supports the legend of home field advantage. Okay. So then you will then practice some of these on your own. Hopefully you understand how to compare the p-value to alpha, how to make a decision, and how to decide, write your evidence claim about HA, and make sure you answer any other questions asked. All right, so good luck to you on your assignment.